Okay, so we're just going to look at a quick example of creating a vector equation of a straight line. This question has come from the old specification from Edexcel, from their C4 module. So the wording is roughly what you would expect, but obviously the question will look quite different, might be in context, and certainly will have multiple parts to it. So I've adapted this, just pulling out the key bits for this topic. So we're relative to a fixed origin. We know we always work that way in any sort of vectors problem. So we've got our relative to a fixed origin. The point A has position vectors. So we've already been given the vectors for these things. We haven't been given points and need to work out vectors. They've effectively taken that first step from us. The line L1 passes through the points A and B. Find a vector equation for the line AB. Well, I would never do a question like this without some kind of diagram, and it's going to look suspiciously like my previous diagram because I don't actually care about it being quite so correct, sort of geometrically. It's just a sketch to help me figure through this thing. So I'm going to find the direction vector AB. AB can be found by doing the position vector B minus the position vector A, which we already have. That's minus 1, 3, 8, minus 2, 4, 7. Hopefully you're working along with me. You're probably far quicker, but do keep going as you want to. So we get 1 minus 1, 1 as our direction vector. So our line is made up of multiples of the vector 1 minus 1, 1. And then we need to add one of our position vectors in to fix our line in space and prevent it from being just any old multiple. You can pick either one of your position vectors, so that's fine. And don't forget it's an equation, so we do need a left-hand side, and our left-hand side is our generic R. Any position on the line is equal to, we'll start from the origin, work up, and then move multiples along the line. Part B, we're told that the point P has a position vector 0, 2, 3. L2 passes through the point P and is parallel to the line L1. Okay, well, here's our line L1 again. We've got our points A and B, we've got a line through them. We've then got another line parallel to it, and on that line there is some point P. Well, we know that parallel vectors are just multiples of one another. So all we're doing then is just taking that same direction vector, the thing that dictates the orientation of our line, and saying it must be a multiple of it. Notice I've used a different Greek letter here. I've used mu instead of lambda because I don't want to dictate the same rate of movement up and down that line. So just to show it's different, but it's still just a multiple of the direction vector we found in part A. And this time we're not fixing it in space using A and B, we're fixing it in space using P. And so here is our second line. And that's it.